Hi everyone, in this video we will learn projectile motion. The definition of projectile motion would be an example of curved motion with constant acceleration is projectile motion. Now there are two things. One is curved motion and then constant acceleration. So if there is a curved motion and constant acceleration, we call it a projectile motion. So let us draw the graph of a projectile motion. What happens? An object is thrown up and then it comes down. That object which goes up and comes down, that object is called projectile because it is projected. Now, what kind of motion is this? First of all, we see that this motion has only two things. One is the height. So y-axis is all about height. And x-axis is all about the distance. So the particle or body in motion is called projectile. All right. Now, what are the basic things? One, that this motion is done in the influence of a constant acceleration, that is acceleration due to gravity. So this g works every time throughout this motion. And what is the direction of acceleration due to gravity? G, that is always downward towards earth. Hence, since we mentioned that it has only two things that happens, that is, it attains a height. Here it attains the maximum height and also it attains a distance, this distance. That's why it is a two-dimensional motion. Two-dimensional because only height and length is considered. So no breadth. So that's why it is a two-dimensional motion. Now let us see what happens with that projectile, the object which is projected. So at the initial point when it is projected, it has a velocity. This velocity can be your v, and at the very initial point, which is 0, the angle between the x-axis, the positive x-axis, and the direction of projection is theta. And then after a certain point, when the projectile reaches at some other point, again the direction of velocity changes. So this can be your v1. Why? Every time the direction of the projectile, or maybe the velocity of the projectile, the direction of the velocity is the tangent of the trajectory. Trajectory is the path which this projectile covers, the path, this curved path. So direction is tangent to the curve or tangent to the trajectory. And when we do a bit of mathematics here, what do we see? We see that this v has two components. One towards the x-axis, like this, and another towards the y-axis. And when we meet this, then we get the x component and y component of this velocity. So let's Vx be the x component of the velocity in towards the direction of x, which is v cos theta. Why cos theta? It is basic mathematics. But for here, I will just tell you, whatever we project towards x-axis or the x component, we multiply with it with cos theta. And Vy, the component of the y-axis, would be V sin theta. Also, it is important to note that acceleration works only in the y-axis because it is downward. So it only works in the y-axis. For the horizontal means the x-axis. For the horizontal component of g, so g of x-axis is actually 0 because there is no acceleration in horizontal direction. So we can write acceleration in y-axis is minus g because it is going downward, and acceleration towards x-axis is actually 0. Now let us describe this motion. It means let us make equations of this motion. For that reason, first of all, we need to learn that what happens when this projectile motion happens. A projectile is projected and it reaches a certain point. So this whole distance is what? What is the formula for distance? This is the distance in x-axis. So what is it? It is actually Vx, the velocity towards x-axis, multiplied by time. Or we can write x is equal to v cos theta into time. So this is our first equation. This says the distance that the projectile attains towards x direction. That this distance is also called the range of the projectile. Okay, so this is the range of the projectile, which we will come to know. Then we have all about what is the height, the y component, the distance traveled in y component. For that, see why I have used only Vxt, and because second equation of motion is x is equal to ut plus half at square. We are not using this part for x-axis. Why? Because we already know that in x direction acceleration is actually 0. That's why this whole term will become 0 because we have a here. So we will only focus on something which has no a. So ut has no a, so we are focusing only in the first part of the formula. But when we describe the y component, then what will we do? We will use Vyt plus half at square. Now y is equal to, what is Vy? Vy is v sin theta into t. Now let us see what is a. Already told you that a is ay, because we are talking about ay. Ay is actually minus g. So this will be minus half gt square. So this is your y-axis. And this becomes your second equation. Now if we put the value of t in this equation, which is y is equal to v sine theta t minus half gt square. If we put the value of t, because from the first equation, which is x is equal to v cos theta into t, what do we get the value of t? T is equal to x by v cos theta. We are taking t one side and transferring everything on the other side. Now the value of t can be put in our equation. Then this y will become, y is equal to v sine theta t, and in place of t, what do? We will put the value of t, which is x by v cos theta. So this is x by v cos theta minus half g x square by v square cos square theta, because we need to square the t. So what do we get? We get y is equal to, see, v and v will cancel, so we have sine theta by cos theta, that is tan theta. So v is equal to tan theta into x minus g by 2 v square cos theta square or cos square theta into x square. Now you can see that in this equation, y is equal to tan theta x minus g by 2 v square cos square theta x square. In this equation, what we can see, this equation is actually, it has x components also and y component also, or maybe it has x and y. So this can define the path of the projectile, and this can also be said as the equation of the trajectory of the projectile. So this is the equation of the trajectory of the projectile. And if we find something very much similar in mathematics with this equation, then what do we find? We find that y is equal to cx, it can be y is equal to bx minus cx square, where this tan theta is replaced by b, and g by 2 v square cos square theta can be replaced by c. So this equation is the equation of a parabola. So the projectile behaves like a parabola. The trajectory of the projectile behaves like a parabola. So it gives a parabolic motion. And we need to know three things when we talk about projectile motion. The first one is time of flight. The second one is horizontal range, or the range. That is the length of x-axis that the projectile attains. How far it goes means. And third one is maximum height attained. So only three things you need to know. And we need to describe the motion, which we have already done. How do we describe? That is in x-axis and y-axis, and then we come to know that this is a motion of of a projectile is actually a parabolic motion. Alright, so we will discuss time of flight, horizontal range and maximum height attained. So to know the time of flight, how long the projectile was above the surface or in the air, we need to understand that there are 2 points here and another point when it drops. These are the 2 points which is like between this points, between when the projectile reaches the another point. During that period, the projectile is actually in air. So if we work on the equation of y-axis, we will come to know that we will be able to find the time of the flight. So we will simply use this formula y is equal to v yt plus half at square. Now first of all, we need to know when projectile starts from a point and it reaches at the ground. In the y-axis, actually it reaches the same level. So total y, there is no change in y, like there is no change in height. It attains height, then again it comes back. So y is actually 0. We have y is equal to 0. And Vy is already V sin theta t minus half gt square. How do we know that? Because a is equal to minus g. Now this part is 0. LHS left hand side is 0. What do we need to do is simply we will take any of the quantity at one side. So minus half gt square can be taken at the left side, which will make it plus half gt square, and this side we have v sin theta t. We can cancel this t and we can remove the square, so we have only one t in the left hand side. So this t is the time which is equal to, this 2 will go to right hand side, so it will be 2 v sin theta by this g. So this is your time of flight or t. Now another important thing we need to know is horizontal range. Or the distance attained by the projectile, which happens only in x direction when it hits the ground. So this length, we have already discussed this length as the x distance, which is Vx into time, and Vx is V cos theta, and time we have already got here, which is 2v sin theta by g. So all we are getting is v into v is v square, and then 2 sin theta into cos theta by g. And from mathematics, as you know, 2 sin theta into cos theta is sin 2 theta. So this will be v square sin 2 theta by g. So this is your range r. Now here, if somebody asks you that by which angle should we throw the projectile or any object so it should reach the maximum distance, then you can see in this equation that v is a velocity, that is fixed. We need to only work on the angle, because g is constant, v is fixed. So what can change? Only sine 2 theta. So sine has the maximum value when theta is 90 degree, because sine 90 degree is equal to 1, and less than anything or more than anything we will get some different value, 1 by 2 or maybe root 3 by 2. Okay, so maximum value is when sine is 90 degree. So sine, we have sine 2 theta, so sine 2 theta should be sine 90 degree to give the maximum value. So that's why theta is 45 degree. So when you throw any object at an angle of 45 degree, it reaches the maximum distance. It goes the farthest. Then at last we will know what is the maximum height attained. Maximum height attained. Now let us find the maximum height attained. For that we need to understand that at the highest point, this point, at the highest point, the x component of v has some value because it is going forward. But it is not going up any further, because at the highest point it will start falling down. So the y component of v is actually 0 at the highest point, because at the highest point, when it reaches the highest point, it is not going any further, and for a very small instant it halts, it stops, and then it starts falling down. So at the highest point the y component of velocity is actually 0. So when we use this formula that vy is equal to uy plus at, v is equal to u plus at, then what do we find? We see that our initial velocity was v sine theta, and final velocity at the highest point is 0, and time is t, which we can replace by whatever the time is given. But we need to find, let me tell you that our a is minus g, so it will be minus g into t. So at the highest point our time is, so we will have gt is equal to v sine theta, or t is equal to v sine theta by g, which is exactly half of the total time elapsed. We have learned that time of flight is 2v sine theta by g, and here the moment it reaches the highest point, the duration of time when it reaches the highest point is v sine theta by g. So when it reaches the highest point, we can have this equation y is equal to uyt minus half gt square. If we put the values of t here, we can get the highest point, or we can get the height attained, maximum height attained. So this is your formula of y-axis. We will just put the value of t, because this time is the time when it reaches the highest point. So simply we will put the values. Uy is actually v sine theta, and our time is v sine theta by g. Then we have half g v sine theta by g whole square. Okay, let me erase few things from here so that we can see it easily. So your y is the highest point, the height is v sine theta into v sine theta. It will be v square sine square theta by g minus half, and here you can see this will be v square sine square theta, because we are squaring the whole term, by g square, and we have here another g in numerator, so we can cancel this. We will remove the square sign, and then we have y is equal to v square sine square theta by g minus half v square sine square theta by g, which is actually half v square sine square theta by g. So the maximum height attained is y is equal to half v square sine square theta by g. So that's it. This is all about projectile motion. Hope you have understood. If you get any problem, please come back to me in the comments. Thank you.